In this video, I want to talk about the inverse tangent function, also known as arctangent. So I've talked about this in some of my other videos concerning inverse sine and inverse cosine, but remember that the inverse tangent can also be written as arctangent. And also, one thing important to remember is that the tangent to the -1 is not the same as 1 over tangent, which is cotangent. Tangent to the -1 is just our way of denoting that we're finding the inverse tangent. Also, we've talked about this. If we look at the graph of tangent down below, in order for tangent to have an inverse function, it has to be 1 to 1, which means it needs to pass the horizontal line test. Now, if you look at this, it clearly does not pass the horizontal line test. It touches, because when you draw the horizontal line, it touches more than one place, which means it's not 1 to 1, and also means that you can't find an inverse function. So what we can do is we can restrict the domain of the tangent function, and I'm going to restrict it between -pi/2 and pi/2, right here, which means we're not going to even think about the angles on either side. We're only going to focus between -pi/2 and pi/2. So for this, as you see, now it passes the horizontal line test. So this function is 1 to 1. Therefore, we can create an inverse tangent function. So for this, what I've drawn, we have restricted the domain between -pi/2. Let's see, that goes from -pi/2 to pi/2. And if you think about the range, now the range is the y value. So remember the range, this thing goes down forever and it goes up forever. So my range will be -infinity to +infinity. All right? So now let's talk about the inverse tangent. Now remember, inverse tangent, to create this, you basically are swapping your domain and range. You just switch them. So that means now our domain of the inverse tangent would be -infinity to +infinity. And our range will go from -pi/2 to pi/2. So now remember that the arctangent, my answer is some kind of angle. It's theta. And we've just stated that our range should be somewhere between -pi/2 and pi/2. So let's look at this on the unit circle. Okay, we have -pi/2 down here and pi/2 up here. So our answers will be somehow limited between -pi/2 and pi/2, which is quadrant 1 and quadrant 4. Now, where is tangent positive and negative? So if we remember from our little all students take calculus chart, we know that tangent is positive in the first, right, in the third, and it's negative in the second and fourth. Now, we're not considering the second and the third, only the first and fourth. So we know that our tangent, if it creates a positive tangent, that happens in quadrant 1. And if tangent ends up being negative, that's in quadrant 4. So let's work a few examples. Okay, for number 1, we have the inverse tangent of 1 over the square root of 3. We're trying to find out what that equals. And so we know the arctangent always equals a theta, an angle. So it's always good, if you want to, I like to rewrite it. That's the same thing as the tangent of theta equals 1 over the square root of 3. We're trying to find that angle that creates 1 over square root of 3. So if we look over at our chart, where's the tangent? 1 over square root of 3, and that happens at pi/6. So our theta is pi/6. Remember what we were talking about when we had our quadrant? Remember, our answers go between quadrant 1 and quadrant 4, and we know that the tangent is positive in quadrant 1 and negative in quadrant 4. So the fact that tangent equaled positive 1 over the square root of 3, that means my angle is a quadrant 1 angle, and so it's positive pi/6. So in number 2, we have the arctangent of -1 equals theta. Let's rewrite it. The tangent of theta equals -1. Okay, so for in this case, if you notice, our tangent creates a -1. -1 is quadrant 4. So let's try to figure out our reference angle. Where is tangent? +1. So if we look at our chart, tangent is +1 at pi/4. So my theta is pi/4. But now remember, since tangent in this case equaled -1, that means my theta should be a negative pi/4. If we look at it, right, quadrant 4, it just means it goes in the negative direction. We're going to refer to it as negative pi/4. So my answer is negative. It's just easy to remember. If we have tangent equals negative, then my angle is negative. It's just the reference angle. Just put a negative on it. If it's positive, like in number 1, then you find your reference angle, and that's your answer. Okay, now for number 3, we have the inverse tangent of 0. So if we write it, where is the tangent of theta equal to 0? So if we check over in our chart, up in the top right-hand corner, where is tangent 0? It happens at 0. So this is a really easy one to answer. My theta is 0. Okay, for number 4, we are looking for cotangent. So this is the reciprocal, so we can rewrite this. The cotangent of theta equals -√3. Now we want to go through tangent first. So we know that the tangent of theta, now remember cotangent is -√3, and you could put that over 1. So if you flip it, the tangent would equal -1 over √3. And this is what we want to find. What theta creates the tangent equal to -1 over the √3? So let's find our reference angle. So if we go up to the chart, where is tangent? Right here, 1 over the √3. That happens at pi/6. So my theta, my reference angle is pi/6. But remember, because the tangent was negative, that means our angle is negative, because the negative tangent lies in quadrant 4.